Good day everyone, today I'm going to present my Flutter project entitled FuelTrack or Fuel Efficiency Tracker Application. FuelTrack is a mobile application developed using Flutter for the front end and PHP with MySQL for the back end and database. So the purpose of this application is to help users monitor their fuel consumption, fuel expenses, distance traveled, and overall vehicle fuel efficiency. So this system provides user with an easy and organized way of tracking fuel usage and analyzing vehicle performance. So for the backend of our applications, I used PHP and MySQL. The backend is responsible for processing users' requests, storing records, retrieving data, and generating analytics. So db.php. So the db.php file is responsible for connecting the application to MySQL database named Fuel App. It also handles the core's permissions and JSON response settings, so the Flutter mobile application can communicate properly with the backend server. So this file serves as a main database connection by all the other PHP files. So next is the add record.php. So this file is responsible for the adding new fuel records into the database. So these codes receives JSON data from the Flutter application, validates users' input, calculates fuel efficiency, and inserts the data into the database using the prepared statement for the better security. If the process is successful, the system returns the message, record added successfully. Delete record.php. So this file removes the selected fuel records from the database using its ID. So these features allows the users to manage and delete unnecessary records from the application. Next is the getChartData.php. This file provides data for the analytics charts. It groups fuel records into daily, weekly, monthly, and yearly reports. So these records are then displayed as the graphical analytics inside the application. The getRecords.php. This file retrieves all the saved fuel records from the database and displays them inside the recent records sections of the application. It fetches the records from the database and converts them into JSON format so they can display in the mobile application. Summary.php. So the file computes all the overall statistic of the application, such as the total fuel cost, total distance traveled, and average fuel efficiency. So these values are displayed in the summary cards found on the dashboard. UpdateRecord.php. The UpdateRecord.php file is responsible for updating existing fuel records. It receives updated information from the users who calculates the fuel efficiency and updates the selected record inside the database. So for the front end, I use Flutter, which handles the user interface and the user interactions of the application. So in the main.dart, the application starts with the main function, which runs the MyApp widget. The MyApp class contains the overall design and themes of the application, including the colors, buttons, cards, and input fields. The app colors and the theme data are used to customize the appearance of the application and make the interface modern and user-friendly. The fuel record class serves as the data model that stores information such as vehicle name, fuel type, liters, distance, and fuel efficiency. The API service class handles communication between Flutter and the PHP backend by sending HTTP requests and receiving JSON responses. So this is the home dashboard of the application. At the top of the screen, the system displays the summary cards showing the total distance traveled, total fuel cost, and the average fuel efficiency. Below of the summary cards is the recent records section where all the saved fuel records are displayed Each record contains the vehicle name, fuel type, liters consumed, distance traveled, and fuel efficiency. The user can also edit and delete records using the buttons provided. The edit button allows users to update existing records, while the delete button removes unnecessary records from the system. The floating plus button is used to add a new fuel records into the application. When the user taps the add button, a form appears where the user enters the vehicle name, vehicle type, liters, fuel price, odometer reading, distance traveled, and fuel date. After submitting the form, the system automatically calculates fuel efficiency using the formula fuel efficiency equals distance divide liters. This formula determines how many kilometers the vehicle can travel per liter of fuel. There's also an analytics page. The analytics page displays the charts and the graphical reports such as fuel efficiency trends, fuel cost charts, and fuel type breakdowns. This analytics help users analyze their fuel expenses, vehicle performance, and fuel consumption behavior over time.